You can find out how long you can make your strings, but yeah, that's it. Just to be clear, it does its work, but I will show you first the My Settings tab, which will allow you to create the location and add the PV modules that are not in here. Good for you to know. If you add the PV module, only you who has this account will see this module. Yeah, mainly because if it's not correctly filled in, then everybody will have a problem. So you can add your own. The location, as you can see, I just tried one, but I would not recommend it. One of the things is, I don't know how they do things in China, but we need to fill in longitude, latitude and altitude. Yeah, if you know the exact coordinates for that, fair enough, but I don't know them. So I skipped that part. Yeah, I told Huawei to change this, so I hope they will. But just choose something nearby. Because, like I already said, Huawei is this tool, and like many other tools, are just using formulas to calculate the energy. So it's not actual energy, depending on, doesn't matter which brand it is, they don't really know the shadowing, the sun hours and everything. It's just a formula based on some static data somewhere they picked up. The PV modules though, you can just create them. As you can see, I added a lot of them. Just fill those parameters, mainly what you know anyway. You can find it on the data sheet. When you fill this in, you can use this module. Then you create one, give it a name, select the project type. Would you rather have a commercial or a residential? Not altogether, commercial then. 3-phase, region, Europe. Okay, I will ask him to add some more. In this case I will add Stockholm. Good thing to know. During the day, what is the lowest temperature you calculate here with? We use in Netherlands -10, but what do you use here in Sweden?
-25. -30 they use most of the time.
-30, -25, okay, we will, yeah, fair enough, 30 then. So that will mean you will have very short strings here. And then you select the AC.
Short string, the short strings?
The voltage go up with the lower the temperature.
But not above open circuit voltage.
You will see that when we put in the inverter, you will see how the length of the string will affect the max DC voltage. Okay. I have a question exactly on this. It's a problem I run into a lot.
Any suggestions for some modules? Or does it matter?
Tina?
Tina? Do you think? We have the button Auto Design. I would not recommend to use that. It gives more than a headache than a good solution at this moment, so just don't use it, okay? I have chosen 240 panels, 70 something kilowatt. I would choose the 60 KTL in this case, one inverter. And let's see, normally in Netherlands we can use 20 modules in a string, which means 2 strings for 40, but you will see that in this case, yeah, right, that's not true. Okay, funny part is, because it's a great tool, sometimes we can see it tells us 846, 64, sorry. We press OK. You see it rises up to 934. Like I said, this tool has some bugs, so you need to be a little bit smarter and then go back. And now we can actually say that this works. Let's see, 21. Oh, still works. That means 22. Oh, it's not working. Well, 1028 will work, of course. The input of the inverter will accept it. It will give you an alarm, not produce energy. And when the temperature rises and it goes under the 1000 volts, it will produce energy. It gives you the availability, mainly this is used more in warmer countries because they don't have this issue, to use longer strings. Where we have to deal with more colder environments like here, I would recommend not to do it because, yeah, then mainly you will always have this problem above 1000 volts and the inverter will not produce energy. So here I will always suggest to not go above the 1000 volts. Your question?
Yeah, so when you put in the panel, what is the voltage that you use to calculate this one? Because when I try to calculate it by myself, I always end up where I shouldn't. I'm not entirely sure which number in the data sheet for the panel that is used for this one. Is it the open circuit voltage?
It's a combination. You need a formula to calculate by yourself. It's not just one number, right?
Yeah, I have an easy way to do it. I think you take the open circuit voltage and then the temperature coefficients, which you can use as a percentage, with the difference about the STC until to the minus degrees. And normally it's 35 because it's minus 10 with us. In your case it will be 55. And you can roughly get some numbers. But indeed, it's what he said, it's a special formula. I don't know that one from my head, but that's how they calculate it.
Yeah. So the open circuit voltage, according to the datasheet, at STC, that's actually not the maximum voltage, open circuit voltage. Because when it's in below 30 degrees, it's going to be even higher.
Yep, you need to check the temperature coefficients, which is 0.3934, whatever what it is, depending on the datasheet. That one you need to take in consideration. And like I said, you can take that number. I have this formula somewhere written for myself, but I'm not a mathematician, but so you can take that one and then the percentage, the difference between the STC and in this case 30.
Degrees.
The STC is 25, and you use here minus 30, so there's a difference of 55. Yeah. And that you need to calculate. Then you will get a percentage about the extra voltage you get on the open circuit voltage. So let's say the open circuit voltage is 40 volts, then this percentage will come around 55, let's say, just from my head. And that's the voltage you will have at minus 30, and then you calculate the maximum strain. Okay. Somewhere like that. I could be wrong somewhere on the path, but it's just something like that.
That's an eye-opener for me.
Yeah, because I have a lot of people also in Netherlands call me and say, yeah, I calculated that, you have too long strings. No, but I'll calculate. I just took the open circuit voltage times 20 and I say, yeah, but you did not take the temperature coefficients with it. And then I say, oh, well, why? Yeah, but that's how it should be done, because that's why it's set.
So you need to find that formula, because it's not from the datasheet, something you can just
read out. The simulation works as well.
Yeah, for this.
Yeah, this one or whatever tool you use.
Yeah, SMA has it, Fronis has it.
Yeah. You can, and if you don't trust one, you just do it on the other one, because that formula is same for all of them. The only you should know which the maximum input voltage of the inverter. And in some cases, Huawei has 1000 volts. Some other brands have maybe 900. I don't know, but I think all of them go out until 1000 volts.
What happens if you exceed the maximum allowed DC voltage, like exceed 1000 to 1010?
So if you exceed this one, let's say you have this case. For the inverter, it doesn't matter because it can use up to 1100 volts, 1100. Only good thing to know is your panel probably is only certified to 1000 volts, your cable is only certified to 1000 volts, and your connector. So for the inverter it's fine, but if your panel breaks, your problem. So sometimes we see in warmer countries people will use the 1500 volts solar modules and then go up to the 1100 volts. But when the inverter rises above the 1000, it will not produce any energy. It will give you an alarm, it will say high input DC string voltage, and then it waits until it gets warmer, so the voltage decreases until less than 1000 volts, and then it will start producing.
Could you explain the difference between starting voltage and like MPPT interval range? It's often like 150 volt starting range for some inverters, and then 200